In this module, you'll learn to create your first model. I have already prepared a project and a model file for us to use. The green text at the top of the file is automatically generated. The green color indicates that we are dealing with a comment, and comments will have no effect on the model itself, but it can be useful for providing commentary. A comment spanning a single line can be started using a double slash. Any text hereafter will be ignored by OPL Studio. If you start with /*, anything after that will be ignored until OPL Studio encounters */. That is what creates the comment that you saw initially. You are strongly encouraged to use comments liberally to explain what you're doing in your models. It'll make the model easier to read for you later, and it'll also make it easier for anyone else to interpret your work. Any model file can usually be divided into 3 distinct parts. The first part concerns variable and parameter definition and any pre-processing you want to apply to these. The second part concerns the model, and the final part concerns the post-processing that you want to do on the results of running the model. To start actually writing our model, the first thing we need to declare is our decision variables. A decision variable is declared using the keyword dvar, and then we are going to specify what type the decision variable is going to be. That could, for instance, be a float, that is a floating point number, and we also need to specify a name for it, and that could be, in this case, x1. Alternatively, we could limit ourselves to only having positive floating numbers, and we can declare such a decision variable like this. Note the plus after the float. Should we wish to instead use integer values, we can declare our decision variables like this. The first decision variable here, x3, is just an integer, whereas x4 is a positive integer. Finally, we have the type Boolean, and in this case named x5. A Boolean value can be either true or false, and can also be interpreted as 1 and 0 respectively. For your convenience, I have added comments showing some examples of values that could later be assigned to these decision variables. You will find as your model grows in complexity, it'll become increasingly difficult to write all of the decision variables explicitly. If you want to generate them in a systematic fashion, I refer you to the module on ranges. If, on the other hand, what you want to do is declare some parameters, that is, some part of the input to the model that is not decision variables, you want to declare them like this. First, a type, int in this case, then a name, I, and then you usually want to initialize them, that is, set them equal to something, in this case 10. Instead of int, you can of course use float. The next step is to actually start defining the model that we are trying to solve. The first thing we need to specify is the objective function. The first keyword that we are going to use is either minimize or maximize, depending on what you want to do. In this case, let's maximize. Then we are going to write an expression. That is the expression that we are going to maximize. It should depend on some of your decision variables, of course, but it can also use the parameters if you so prefer. So let's come up with a random example. We could just keep it to maximizing x1, fairly boring stuff. We could add x2 and even x3 to it. We could multiply x3 with 2. We could also multiply it with I. We just have to remember that this function needs to be linear in the decision variables. If you just tried to optimize this, OPL Studio would of course just choose the maximum obtainable value for x1, x2 and x3. That's fairly boring. What we need to do is subject the maximization to some constraints, and you do that by writing the keywords subject to, and then you enclose the constraints in these brackets. A constraint could just take the form of saying x1 should be less than or equal to 100. That's valid. You could also use multiple decision variables, so x1 plus x3 must be less than or equal to 1000, perhaps. You could also use x2, and you can continue this procedure as much as you want. It doesn't have to be less than or equal to, it could also be greater than or equal to. You can even mix the decision variables on each side of the inequality if you prefer. The only condition is you need to keep the constraints linear in the decision variables. You cannot just say x2 times x3, for instance. Having created the model, let's create a run configuration. And never mind the name. Add our model to the run configuration and run it. If we resize this area, you can see that there are 3 warnings, and these warnings are for variables that we are not actually using, in this case decision variables. But if you go over here and check the solution tab, you can see that it actually finds some values for x1, x2 and x3. Thus, you should have solved your first model. To get something actually usable, consult the next module.